Hello, this is Drew. I tutor a number of topics in mathematics, but today we're going to be doing some introductory linear algebra um, about matrices. So the question, as I've written up here, there's actually three questions here, but the top line is supposing that the matrix product AB is defined, and we're asked to give dimensions of certain types of matrices. This first part up here, the idea that AB is defined is important because when you're multiplying two matrices, the dimensions matter. So when it says defined, that means basically you're multiplying A and B and you get like a legitimate matrix afterwards. And they have to follow some dimension kind of rules. The main rule that we're going to be using throughout all three of these problems here is going to be important. So let's say we have a matrix A, and the dimension of that matrix A is, let's say it's dimension m by n. And then we're going to be multiplying that by another matrix B. Now, and to get this new matrix, which we call AB, it's kind of redundant to put this, but I'm just going to put it that way. The rule that we are going to be following is this. Whatever this value is here has to match certain dimensions here. And the way it works is this here, the number of columns of A has to match the number of rows of B. So that must mean that, and let's call this P. That means that whenever you have matrices that are being multiplied together of different dimensions, these middle dimensions must be the same. And we can get into exactly why that is another time, but that's the first thing. And then the resulting matrix will have the dimension of these outside values. So this AB matrix will have the dimension m by p. So that's the main rule that we're going to be using. And once we kind of get that under our skin, it becomes a little bit less intractable to do these problems here. So the first one says if A is 17 by 34 and B is a column matrix, oops, I spelled column wrong, but that's right, give the dimensions of B and AB. So we know that A is a 17 by 34 matrix and B is a column matrix, which basically means it's a column vector, which means it just has one column, right? So one column, boom, means that the second value in this dimension is 1. And as we said before, this middle value here between the two matrices have to be the same. So that means that this has to be 34. So that's the first part here. The dimension of B is 34 by 1. When we multiply these together, as shown here, we end up getting the outside values. So you'll end up getting a matrix that is of dimension 17 by 1. Going here, now we say, suppose A plus A transpose is defined, which is what that means. So A with the T above it is defined. And AB is this, what's the size of matrix A. Now, just to review transpose, if you have a matrix, I'm going to use a 2 by 2 matrix as an example. Let's just call this A, B, C, D. The transpose, so this is A transpose is essentially like taking a little line here along the diagonal and flipping the matrix along that line. That's kind of how you can think about it. So the resulting matrix you end up getting is the C gets flipped up here, the B gets flipped down here, and the D stays where it is. Essentially what you're doing is each column becomes that row in the transpose matrix, and each row becomes a column. So the first row becomes the first column in the transpose, etc. So in order for us to be able to do this and have the sum of these match, that means that the dimensions, when you do the transpose, have to be the same. And the only way that happens is if A is a square matrix. So that's something that we know. So A is going to have the same values in the first and second. The rows and columns are going to be the same. So that's going to be really important because we are given that AB is 43 by 55. And if we take this A here and we multiply it by some, arbitrary B, we're going to get this 43 by 55. Going back to this main rule up here, that means that these two values make up kind of what I'm calling the outside values here. So we know this is 43 here, and this is 55 here. As I said, A is a square matrix, so we don't need any more information. That must mean that A itself is 43 by 43. And then lastly, we have this problem here. If A is a 13 by 16, and AB is 13 by 71, What's the size of matrix B? Similar idea, we have a matrix B here. These two values make up what I again call the outside values here. So that's 13 here, 71 here. The inside, again, has to be the same. So this must be 16. So B ends up being 16 by 71. If you have any more questions, feel free to reach out to me and hope this helps. Thanks.